So, let's begin. Groovy AST Demystified. And think that because of that same topic, there are so many people here interested to know probably what are ASTs and probably most importantly, how can you make your own AST transformations? This was one question that was asked a year ago or so when I gave a similar talk on this topic. So, quickly, who am I? Why do I believe I'm qualified to give this talk to you guys? Well, first, because I love Java. I jumped into the Java bandwagon since the early days, since 95, because of applets. Yes, I know, applets bad, but I like Java. Then I discovered open source because of Linux, and thanks to Java and Linux, I discovered Groovy in 2006. It completely blew my mind away. And 1 year after I kept pestering Guillaume, when this doesn't work, please fix this, he said, you know what? You can fix it. Here's commit access. Do it, please. So that's what happened. And after that, together with two other friends, we created a project called Griffon, which there is a talk tomorrow in case you're interested. And currently working for Canoe, a company in Switzerland. I come from Mexico. That's why my accent is a little bit different. And, well, there is a book in Griffon, in case you're interested. And I'm also one of the few Latin American Java champions. So let's get on with the topic. This is our agenda. First, I will describe what was my personal experience trying to get into AST transformations, why you may need AST transformations, why they are so powerful and why they are what they are. Then we will survey the whole list of AST transformations, at least the local ones that are available in every Groovy distribution. And then we will come to the pièce de résistance. Please, the French guys, tell me if I said it correctly. How to make your own AST transformation. So, first step. We know this guy. This is a standard Java Vim. This is a standard Java. Yes, we love Java. It's very verbose. In order to create a simple property, we know by heart that we had to generate a getter and a setter and so much noise around it. Now, this is me after a while, after I had to deal with this code. Yeah. Okay, one more bean. Yes, I know that the IDE of choice, Eclipse IDEA, which is better, I will say, NetBeans or whatever you want, can generate this source code for you. But the problem with generator source code is that it gets out of date immediately. Because if you had to generate a new property, there goes the generator source code. You had to do it again, change the name, whatnot. It's such a pain. But then in Groovy, I discovered that I can do this. The compiler magically is aware of the Java Beans convention, and it's only a matter of defining the property name and the property type, and boom, I get the property. And what's else? Well, I'm showing here that even though there are no method name, set name, and get name, I can still make use of those. That is because the compiler injected those methods, or pretty much generated the methods into the bytecode. This is me when I discovered Groovy. I couldn't believe my eyes. This is exactly what I was waiting for. Because previous to this, I spent some time in dynamic language land. Yes, I did PHP. Who did PHP before? Yes, I know you guys. I did Perl. I like Perl. And I did some JavaScript. Yeah, before the hipsters came in and say, oh, JavaScript is the best language ever. And it's a true language and whatnot. So yes, I longed for some dynamism inside the Java language, but it wasn't meant to be. But then Groovy came along and I said, hey, this is it. And after a while, I discovered this little project called Grails, which was in version 02 or 03 at the time. This is, remember, 2006. And I noticed something funny, that if I follow some conventions, like this definition of that property and the constraints thing here, then I could do some crazy stuff like calling a method that was not defined by me, neither the compiler, but it will still work. And based on those naming conventions, it will be easier to infer the rules on what those methods could be. And this is me afterwards. Now I'm really interested. What's the new meme? You got my curiosity, now you have my attention? Or is it the other way around? Anyway, I said, I thought for a moment, how are these guys doing this stuff? Well, it turns out there is something called runtime metaprogramming. This is how the Grails at the time was able to figure out, based on those conventions, that this method was a valid one, and it can only be called once the application is running or when your tests are running. Which is great, but I still have to eat. I had to put bread on my table. And at the time, Java was the one doing that stuff for me. Now it's Groovy. Now I'm fine. So I'm not starving, you can see. So I wanted to have this kind of facility to call these methods from Java. Well, not such luck, because again, it's runtime metaprogramming. But then along came AST transformations when Groovy 1.6 was released. And this is the time when we can say we can do compile time metaprogramming. This is exactly what AST transformations allow you to do. Update the code, generate new code, change the code in such a way that it feels that you're doing runtime metaprogramming, but everything is baked into right there in the bytecode. The aftermath is that, yes, you will have this dynamic behavior just running Groovy, but those new additions, those things that you do and you apply to the bytecode are visible to Java code as well. So now it doesn't matter which JVM language you use. If you happen to make use of AST transformations to generate all those blocks of boilerplate code or verbose code, they are already gone. Now you can use them from anywhere. Now for that, if you ever see this guy walking on the street, Dino Ferry, please stop him and say thank you very much. He is the guy that eventually put the first or made the first iteration of what we call the AST transformation framework. This guy lives in Colorado Springs. In case you ever go to Colorado, search for him. So, thanks to him, we can do crazy stuff today. Like this. This is the first AST transformation implemented ever. It happens to be a local transformation, and it happens to be related to desktop application development. Thank you very much. Desktop development application is still important. See? So, there are two types of transformations, local and global. We will start with local transformations because they are the easiest to grasp. What you need for a local AST transformation is first an annotation. The annotation is like an anchor, your entry point. It's where you instruct the compiler something magical will happen here. So we're saying that for that particular class, the model, we will apply some magical constraints. What we're going to do is make this model class an observable one. What does it mean to be an observable class? It means that whenever you update a property value, it should trigger a property chain event. It also means that the class that contains these observable properties should have some life cycle or bookkeeping methods like add property chain listener, remove property chain listener, and get property chain listeners with some variations. All right. So that's it. That's the only thing that I need to do to that class to make it an observable one. And then there comes the example. And you can see that this method is underlined in IDEA. I took this as a snapshot from IDEA. Because this method per se is not really known by the IDE. But it tells me, well, I know it's Groovy and you can add methods at any time. So I'm not going to put this in red squiggly. Because it may be valid for you. Okay, so I trust you. So I add a new property chain listener for that particular bin, and then change the property twice, right there. If you can see it at the bottom, the counter value is equal to 2, because this listener was called twice. All right, perfect. Next example, at delegate. How many times have you wanted or have you need to perhaps graft or apply the behavior of another class into a primary class, but happens that the primary class already extends something? So remember, there is no multiple inheritance in Java. So there's no multiple inheritance in Groovy either. So what we do is use composition. And then we manually or painstakingly, or we ask the IDE to generate delegate methods for us. This is exactly what the add delegate annotation is doing for us. What is going to happen is that the when property, which is of type date, will expose all of its public methods to the event class, so that if the when method, the when field that exposes before and after methods that come from the date class, the event class will also have before and after methods. And that's exactly what we are testing here. We create two instances of two events using what I call the turbocharged POJOs notation. You're just setting properties on it on the constructor. How cool is that? Yeah. Let's go with the redundancy. So we have two events, and then here comes the magic thing. I'm calling the after method on an instance of an event class, but I didn't define the after method. That's what the add delegate annotation did for us. If I happen to change the name of the when property, it will still work. If I change the type, then that type will contribute the particular methods that that type has, and so on and so on. I'm going to show a third one, which is quite useful. Now, in these times, I think most people in the JVM speak about immutability. Why? Because everybody wants to be ready for high concurrency. There are many ways to do it, and Dr. Russell Winder can tell you a few ones. But if you have immutable objects, it makes it much easier to not trample yourself with multiple threads and concurrency and whatnot. Okay, so which are the rules for creating an immutable class? What does it mean to have an immutable class? Well, once you initialize its fields, they cannot change. Those values are set forever. Well, until you shut down the JVM, that is. So the first class is a regular mutable class. I can change the value of the name property anytime I want to. All right? But the second one, now that immutable person class happens first to be final. I cannot subclass it. Okay? Second thing is that this property will not have a setter, will only have a getter. It will be backed by a private final field, so you cannot change it. It will have a constructor. If I have multiple properties, all the constructors that are needed to generate a proper instance will be there. And it should provide a correct implementation, I cannot stress this enough, a correct implementation of the equals and hash code methods. Also, those implementations come from the guidelines of the Effective Java book by Josh Block. And the toString method is useful, but it's not a requirement. And another important thing is that every single type that you use has to be immutable as well. So if you define a date field there, or a class field, or an object field, the add immutable transformation will say, you cannot do that. Because these things, we cannot guarantee that they are immutable. So let's see an example. We create two instances of the mutable one. And of course, these things are not equal. Two different references in memory. But then I'll create two instances of the immutable one. And notice that the equals implementation is okay because it's comparing the objects by the values of its properties. The properties are of the same type and the same value. So these things are okay. The same thing happens if I were to compare the hash code. Now, here, I'm attempting to change the value of the name property of this immutable person. And it should fail with an exception. Read-only property exception. And it does, because this thing cannot be changed. So these are at least three of the different AST transformations that you can apply, what is beautiful about add-delegate, well, of all the three I have just described, is that if I do this thing in Groovy code and then go back to a standard Java project, those additions are visible to my Java code. So long gone are the sessions of generating source code. Just apply ST transformations, and that's it. Build your model in Groovy. If you are still tied to Java source, do it in Groovy, in this case, your model, and then the rest of the application can be still implemented in Java. So the full list of AST transformations, local ones, until Groovy 2.05, I think, is this. You want to generate equals and hash code implementations of those methods following just blocks advice? Apply equal and hash code. Do you need a beautiful two-string implementation? Annotate with @toString. Generate constructors. This guy is actually a combination of the previous two. So just put @canonical, and you get beautiful, well-behaving POJOs. Indexed property. This is another thing for adding properties that require an index. So you can set a value based on an index, or you can get a value. It works with arrays, it works with lists, excuse me, and so forth. There are others interesting ones. This is the second annotation implemented in AST transformation. It allows you to define a script with all of the dependencies in one part of the script at the beginning. Probably is annotating an import statement. And if you ship that script to your teammates, they will be able to execute it without having those dependencies already installed. They only need Groovy. Because what add-grab does is resolve based on Maven repositories or some other mechanism like IB. See where are those jars located? Okay, download them, put it in the class path, and then continue execution of the script. And of course, the new guys in the block, compile static, type check since Groovy 2.0. This is how you can have static compilation on your source code. Here we have others interesting, perhaps. Well, there's bindable. These guys are used to interrupt the execution of scripts based on certain conditions. If you have any questions regarding them, I will direct you to Cedric Shampoo, the author of these transformations. No escape, mate. These guys allow you to inject a login field of the specific type, whether it is Java util login, SLF4j, log4j, or Apache Commons login. These guys not only inject a field of the right logger, they also make sure that your login statements use the right guard. So we know that if we say log info, blah, 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 if this string is complex, it takes a long time to format, we pay the penalty of that computing even if the info level is disabled. So we have to use the if logger info is enabled, then do the proper log info, right? What this guy does is, doesn't matter, don't use the if, we will do it for you. Then add singleton, in case you're still interested in creating singletons. There are many ways to implement singleton. There is only one correct way to implement singleton. This one. And I guess that the other guys that implemented JSR 330 will say otherwise. But you can think yes. And here are a few other ones. Okay, yeah, this is my favorite, craziest AST transformation. Cedric Shampoo is also the author. If you think you can write better bytecode than the compiler, then inside a method definition, put the generated bytecode that you think is better, and then the compiler will say, oh, this method uses add bytecode, so exactly what is inside there, I will put it really directly in the bytecode. I'm trusting you. You say that this is good. Okay. This is quite funky. Any Scala guys in the room? Okay, this one is for you. Scala has its own conventions for generating beans. It also has its own conventions for generating methods that match the operators. Those conventions are not the same as Java and Groovy. But with this transformation, we can annotate Groovy code and make the Groovy conventions match the Scala conventions. So now you can consume Groovy code from Scala using idiomatic Scala. Then we have G contracts that has plenty of transformations for defining preconditions, postconditions, invariants. Grails uses transformations like add entity and test for. I think that now the test mixing is also technically NST transformations is 220. Griffon, of course, I know there's plenty about Griffon. There are many, sorry, many local ST transformations. What about the global ones? Well, there are also some global ones. The only difference now between local and globals is that global transformations do not require an interface. They are always enabled. This is why you don't see them that often. Because if your source code has no need for one of such transformations, it doesn't matter. The compiler will still load them and will try to apply them given the rules. We have graph is half a local transformation, and half local, half global. The GORM API and I think some of the JSP improvements done in Grails 2x are also done using global transformations. Griffon has threading injection and Spock testing framework. Pretty much is a huge, huge global ST transformation. I'm oversimplifying things, but that's exactly what it does. It grabs your source code and says, so funny, the bytecode I'm going to generate is going to look so differently from what the standard Groovy compiler would do. Yeah, pretty much. So, if I have enticed you about working with ST transformations, you may be thinking, okay, that's nice. I can remove duplicated code. I'm able to no longer rely on generated source code. I have identified some portions in my own project where these things can become useful. How do I write my own ST transformation? Well, my friends, this is me when I tried to write my first ST transformation. Clearly, I had no idea what was going to happen. And let me say right now, before I actually show some code, that if you ever decide to write your own ST transformation, be very careful because it's very addictive. It is. I cannot let go. So, writing a local ST transformation, 3 steps. Define the interface. Check. Then implement the transformation. Easy peasy. And finally, profit. Right? Writing a global ST transformation. You have to instruct the compiler that this transformation has to be enabled. So there is a special file inside meta-inf services following this name. Inside this file, you put the fully qualified class name or the ST transformation. Then, of course, second step is implement the transformation. No idea how. And then finally, make use of it. Nice. Okay, so how do we make an ST transformation? Anybody has a clue? We have to work with the compiler. We had to talk to him. We had to tell him what to do. So it's very likely that we had to use the same structures that the compiler uses to understand our code. I don't know how my computer hasn't committed suicide because the code that I write, ugly. Anyway, what we're going to do now is the easiest step. The first one will be, let's create a local transformation where what we want to do is add a new property to our class. Just that, a new property. This property will be an identifier, say like the ID property that domain classes in Grails have. All right. Okay, so first thing, define the interface. This is like any other annotation that you define. We define a rotation policy, a target, you can only apply on types, the name. We are instructing that this annotation will have some kind of entry point. This is the anchor, remember. What we're saying is when the compiler encounters this annotation, it will go and try to locate an instance of this thing, and then delegate the processing of that particular code block to the annotation, to the transformation instance. So let's see that implementation. Wow, easy. First, you must implement the AST transformation interface, which forces you to implement this method. Second, you must tell in which phase this transformation will apply. The Groovy compiler works in 9 phases. Phase number 3 is lexical. It's when you resolve the classes. When classes are resolved. Semantical analysis, right? Right. By that time, your class has been sparse. The AST, which stands for Abstract Syntax Tree, has been filled. So we have an in-memory representation of our source code. But nothing more has happened. Then comes the next phase, canonicalization, which is usually the phase that almost every single transformation uses. Because by this time, everybody else can work, can do the job. If you happen to use a phase that comes after this one, I think is class generation, that's too late. So this is the latest one that you can use. Perfect. So now we have to know what is the secret sauce. So remember, we wanted to add a new property. Okay, let's see. I will recommend following 3 steps. Verify that you have what you're supposed to have. Second, check that the additions that you want to apply have not been applied already. Maybe manually someone defined the property, so you don't have to add it twice. Or somebody added or removed the method that you want to manipulate. And finally, do the job. So the first thing is verify that the nodes, remember, let's go back first. You get these nodes. One will be the annotation. The other is the element that is being annotated. In this case, will be a class node that represents a class definition. So let's see. If the first one is the annotation node, that should be my @identifiable annotation. Okay. Second has to be a class node because I'm annotating types. If those two are okay, I'll continue. Otherwise, say, hey, there's an error. By the way, this is not the right way to throw a compilation error. This is just to do it right quickly. If an exception happens, you will get a compilation error, but it's better if you say something like Groovy bug or some other facilities. Okay. Verify preconditions. I will not add the ID property if it's already there. Cast this thing. Check if it has the identity property. Yes, it has. Then nothing needs to be done. If I need to add the property, then it's something like this. The class node has some very fancy methods to add, remove properties, add and remove methods, even inner classes, static initializers. You can do pretty much everything. You just need to know the names of the classes or the expressions. Okay, so adding a property is quite simple. Name, a modifier, type. If we want an initial expression, in this case, we just say null. And if we need to modify the getter and setter blocks for the generated getter and setter methods for this property. In this case, we don't define anything like that, so it will use the default things. It will do the right thing for us. And for that, I will say, not bad. Easy. Next example, let's do something more complicated. Let's add a new method. What I want to do is something like this. This example. No, that's the annotation. This one. Like that. Okay. I think that's better. Okay, so we have 2 beans annotated with a new annotation called greetable. What we're going to do is add a new method to these beans. And we're seeing here the usage of that new method. We can say, we can send a parameter, and here we will expect that the reply will be hello world. But in this case, we add in a new parameter to the annotation. So we expect now to see how the string. So the trick will be, how do we know, how can we add a method? And then how do we harvest this value from the annotation? First, we define the transformation. Exactly that the identifiable one. We just changed the name here, the name there. We now add a component, a field, actually a method, salutation with a default value, just in case. Well, then again comes the usage of this code. Then the implementation of the transformation itself. Remember, first we verify that we have the correct nodes. Second, we verify that the grid method with some parameters is not added. Because if it is, then we will generate bad code. Then do the work. We grab from the annotation node. Remember, this is the first one. We ask for its member called salutation. If it has some value, if it's of type constant expression, that means it's a string. Perfect, we have something. If it doesn't have a value, then we have to give it a default one. But here we start to see some of the things that I was telling you about. You have to know that this member is of type expression, and it could be a constant expression, it could be a Boolean expression, it could be a binary expression, it could be a expression. So you have to be aware of these classes. Once you have all the information that is required, we add the method. Say what? Looks a little bit familiar like the add property. So we have the method name, all right. Modifier, okay. This probably is the return type, yes. The parameters that actually had to be an array of class nodes. Okay, I probably didn't know that because of that constant. Exceptions that the method may throw. And the method body. We have to return something, so return a new binary expression that is whatever I receive as a salutation plus whatever I receive as an argument. Explain like that is quite simple, but coming up with all those things makes you look like this. Really? Isn't there another way? Well, yes. There are some additional tools that you can make use of. AST browser and the AST builder. The AST browser is available in the Groovy console. So when you run the Groovy console, there is an option after you run a script, say inspect AST. This will bring up a new window that contains a J-tree that defines all the AST nodes that match the script that you wrote. So this is the example for printing hello world. Here we have, let's see what we have. This is the run method that every script has. Inside we have a block statement. Inside we contain a single expression statement that is comprised of a method call. That method call is done inside this variable with a constant print line. That will be the name of the method. And the argument list happens to be hello Groovy here. And here comes the constant. This is the first element on the argument list, hello Groovy. Simple. I don't know why so many people don't make AST transformations. But in this way, you can, if you ever get lost writing AST transformations, if you want to know how would the compiler will write these structures, then write the code in the Groovy console and then run it and then say inspect AST. It's one of the options in the menu. And then you can browse through it. You can even select the compilation phase and see how the AST changes from one to the next. Previously, I showed how to implement the transformations using Java. I prefer to use Java for one reason. Previously, it was supposed to be a speed. The second is because if it's Java, you are not invoking dynamic method dispatch. And because AST transformations, in my view, have to be as fast as possible and as short as possible doing whatever they're doing. Because remember, this is happening during compilation step. We don't want to end up with a very sluggish compiler like the Scala compiler that takes forever to compile your code. In these guys, we want to make it as fast as possible. So dynamic method dispatch, bad. Now with Groovy 2, we can put compile static, type check and compile static on our AST transformations and implement them in Groovy. So you have nice syntax, nice behavior, and fast. So if that is an option, then I will make use of an AST builder. The AST builder can create or generate AST expressions following three strategies. The first one, we give it a string. In this case, will be print hello world. This will generate a block code, a block statement with an expression and everything that we saw previously on this slide. From here to there, with just a single line of code. Not bad. If you want to have a little bit more control, because remember this is just a big string, then we can give it a closure. And based on what is inside here, it will also generate those AST nodes for you. But then there comes the final way. This is still a little bit magical in the sense that, yeah, I trust you guys will do, the builder will do the right thing. But if I really want to create method call expressions and all that, then I can do it this way. It's like an AST DSL. But then you have to know that a block has to contain expressions, and an expression may be of X type or Y type. If it's a method call, I need this and this and these things. Just a matter of learning the DSL. There is a fourth option. This is the one that I use in Griffon. Create your own builder. This is part of a transformation that generates the code required for a class that implements the comparable interface. This is a portion of the compares to method. I put in comments what the Java source code is supposed to be, and what is in the real code is the implementation of something. So let's see the first one. If A and B are equal, then we return 0. Let's see what our builder nodes does. I put an S because it's supposed to be a statement. So if a statement equals variable A and variable B, so that this portion, then I know that this thing will automatically just return the constant expression X 0. Okay, so it's just a matter of learning a little bit about those methods. Let's see something else like this one. Return a.property compared to, that's the compare to operator in case you didn't see it before. It's called spaceship because it looks like an UFO. B.property. Okay, so return statement, compare, that's this guy, property from variable A, which property name that supposedly will be this guy, then that name, and then the second property. So it's really quite readable. And here's another example, I believe. Definitely more complex. And here we're even doing a loop on our properties represented by property nodes, and for each one of them, we do this. So really not that difficult, even with plain Java code like this one. So as you can see, plenty of options. After a while that you have played with AST transformations, this is how I felt. Yes. Now I can break the compiler. No, sorry, I can do great stuff with the compiler. And I say that it's very addictive. There are 8 or 9 local AST transformations in Griffon, 6 global transformations, and 20 plugins so far, each one of them with their own AST transformation. There are 32 more to go. If you really want to avoid going down that path, Enjoy using AST transformations. Don't create your own. Learn from me. So I think that I have 5 more minutes left for questions, in case you have some. Um, Otherwise, please continue enjoying the conference. There's still one more full day of talks and grooviness. Remember, there's a talk on Griffon tomorrow, in case you're interested. So, questions? I know you have some questions. This is not that easy. What would be the proper way to know if something is wrong with the compiler? Well, if we did something wrong with the AST transformation itself. Yes. There is a specific exception called compilation exception. There is another method available to a base abstract AST transformation, which I didn't show. That base abstract transformation comes from Groovy distribution, which should provide a method called GroovyBug, and you give it a message. And this will generate the right exception for you and will fill whatever additional information is required for the compiler to say in line X and Y the error occurred. How do you test these things? Right now, I do it manually, but that's because I'm crazy. There is a AST transformation test case that you can make use of. You can only test a single transformation at a time. I have seen other people in the Groovy team. What they do is they sorry, that's my alarm. I'm out of time, almost. They generate the target code as a big multi-line string, then create a compiler configuration and a Groovy compiler, put everything together, and call compile on it. If there are no exceptions, then it compiled. Now you have to verify that the generated class has what you expect it should have. There's another one. So we have an AST test console. Ooh, sexy. Groovy 2.1? Perfect. See, as I told you, guys have more questions about ASTs? That's the guy. Yes, jump on him. Gotcha. Any more questions? Yes.
Not really a question, but an advice I would like to get people who want to learn AST, because there's not that much documentation, to be honest.
There's definitely not that much.
I discovered this class which is called the Groovy Welcome Spec test case, written by Headlight.
Mm-hmm.
And basically it's a test case with all the situations you can encounter to build AST. And it's a really great source of documentation to learn how you can add a method, add a property. So you should really look at this class. It's more than a help than the documentation.
Yeah, that is true. The documentation is lacking. You will find some in the Groovy website, but just because I'm a hacker, the best documentation that exists is the implementation of the standard AST transformations found in the Groovy distribution. So just go to GitHub, browse the package that's called OurCodehouse Groovy Transform, and then you will see lots and lots of AST transformations being implemented. Yep. So thank you very much for your time.